in this last video for L'Hopital's rule, we're going to look at, I put weird exponent. Yeah, it looks like the limit as x approaches 0 from the right of x to the x. So when I say weird exponent, I mean an x in the exponent, a ln x, a tangent x, a sine x, just some weird funkiness. You'll know them. They're at the end of the homework assignment. All right, so what we're going to do is we want to use L'Hopital's rule. This is not a fraction. So how the heck am I going to make it look like a fraction so it'll be 0 over 0 or infinity over infinity? So the first thing that we do is we're going to cheat a little bit and we're going to say, okay, we're going to assume the limit exists and it equals L. Okay? And to get that exponent to a spot where I can do something with it, I'm going to take the ln of both sides. Okay? So what I'm going to have is I'm going to write the limit as x approaches 0 from the right. Okay. And I'm going to throw an ln in and ln L. Okay. Now, what my goal is for the whole problem is I want to find L. Okay. How I'm going to find that is I'm going to basically be a little bit creative. I was going to say cheat, but it's not cheating. It's just being creative. So what I'm going to do is I'm going to work on this side until I get an answer, and then I'm going to try and solve for L. Okay. So let's just work on this side of the problem. So if I work on this side, by properties of logs, I can bring that down. Okay. Awesome. It's still not a fraction though, right? So if it's not a fraction, I need to somehow manipulate this to get it a fraction. So I'm going to take that x, and I'm going to write it as a 1 over x. Okay, so make sure you believe it. X is down in front. That's the same thing as dividing by 1 over x, because that would flip up to be an x. Told you it was creative. Okay, now when I plug in 0, the ln of 0 is going to infinity. Okay, so as I'm approaching 0 from the right, this is going to infinity. 1 over 0 from the right is also infinity. I get infinity over infinity. It checks out. I get to use L'Hopital's rule. Okay, so here I go using L'Hopital's rule. The derivative of the ln of x is 1 over x. The derivative of 1 over x is negative 1 over x squared. Okay, this double stack fraction will flip up. This will be the same thing as 1 over x times negative x squared over 1. So I believe this will just reduce to a negative x. And when I plug in 0, I'm going to get 0. Whew. Okay, we're not done though, because I sort of creatively threw in an ln. So here's what I have. If I pan back up, this whole side equals 0. So this has got to equal the ln of L. So I'm going to take these two together, and I'm saying that 0 has to equal the ln of L. Well, I need to know what L is. That was my goal, right? What was L from the very beginning? So to undo this ln, I'm going to write a big E on both sides. So L is going to be e to the 0 or 1. Okay. You might have to watch this video a couple times to see the method, but you're going to use these on the last couple problems in the homework assignment. So good luck.